Hey, good evening, everyone. Thank you, Mary, for that introduction. We're going to be talking about the exploration of Mars and, of course, the latest news about the red planet. I mean, this is changing day to day, so this is kind of pushing it a little. What's new today is old hat next week. So we'll see what happens here. So, okay. This is all about Mars. Surface gravity is about 38% here. So if you weigh 100 pounds here, you're only about 38 up there. It's similar to Mercury because Mars low density. Mercury's composition is mostly like the cliffs of basalt that we have here in the Palisades and the Watchungs. On Mars, it's a bit less than that. The crust is very thick, though. It's, of course, huge volcanoes. Temperature average on the day, if you like it cold, you got a great place to go to. The average day is about -25, and that's in the summer.
Oh,
Yeah. First, no general magnetic field. It had one once because Mars meteorites. Yes, some rocks actually can be blown off the surface of the red planet, and eventually, rarely, Earth pulls them in, and we can analyze them in our laboratories. They show some magnetism. They may be a solid core of iron, similar to what we have here. Mars meteorites are as young, quote unquote, as 180 million Earth years old. Again, they contain basalts and volcanic minerals. And if you can put them side by side like this, of course, that's our Earth on the side there, all the wonderful ocean water, all the weather patterns and such that you see here. And over here is Pluto Mars. And it does have some weather, but these are associated with landforms. We'll be talking about some of the volcanoes of Mars a little bit later. It has a polar cap. Of course, we have a much more extensive one. This cap, however, is carbon dioxide, dry ice. And during the Martian summer on either pole, most of the carbon dioxide ice, the dry ice, evaporates. And given just an overview of elevation and such, Mars has taken several rather large hits. These two areas here are themselves quite deep. In the case of this particular one, we're looking the one on the we're facing it on the right. Some sections are about 4,000 feet below the surrounding terrain. It has large volcanoes, some of the largest in the known solar system here. And this nice big rift valley that if you could take this formation here and put it on the United States, it would go from Atlantic to Pacific nonstop. So it's quite a large feature. Okay. Well, the planet, we have one large big moon. See it tonight as a crescent. Mars has two small moons, maybe captured asteroids when they're that tiny. Phobos and Deimos is from the Greek. For the two sons of Ares, fear and terror. I just love these great names. And don't feel too bad because he has two daughters too, by the way. And the one is mad, and the other one oversees peace, harmonia. Because we're at the absence of war, there's peace. At least that's what I'm told. Okay. So we have two more names waiting if we find any more. We haven't so far. They may be possible places to stage for landing on the planet in the future. Okay, and we have an anniversary, which is the reason why I'm giving you slides for at this time. 50 years ago, coming up, both Viking probes, we sent Viking 1 and 2 out there to Mars back in 1976. Okay, we sent landers down. Viking 1 was launched on July 20th, 1976. Viking 2 landed on September 3rd of the same year.
Oh.
Okay. First photograph. It seems like everybody, when you send a probe to another world, we always photograph our foot. It's one of the three that are that support the Viking main vehicles. And you can see there's very fine dust around here. Some of the rocks seem very heavily pitted, indicative of a erosion from wind-blown materials. This is Viking 2. Another first photo, but notice that the terrain before was a little smooth. Look at this. Any of these larger boulders could have destroyed the spacecraft. So we got
Like
very
Earth.
lucky. Yeah, we got very, very lucky. Okay. And they were long-lasting robots. Their original mission was only supposed to be 90 days. Viking 1 operated from July 20th of 76 to November 13th. That's 6 years, 3 months, and 22 sols. In other words, 22 Mars days. Viking 2 was from September 2nd of 76 to April 11th, 1980. 3 years and 7 months, 8 sols. But that was not because the spacecraft failed. Somebody on the ground here had an error in their software and it shut down. And once it was shut down, there was no way to reboot it.
Oh.
So, hey, we got some work out of it. So what can I tell you? Shame that, though. Okay. Now, on Earth, we have soil. About half of that is mineral, eroded minerals and rocks. And the other half is organic. Over here, we do not have soil. We have regolith, which is mostly rock. There are apparently very little organic materials in that soil, if you will, that regolith. Okay. Now, one of the big reasons we sent these landers out there was to find out if there was any evidence of existing life, or maybe in the past that it got a foothold for a little while and then Mars cooled down, may have froze out, and that would be the end of that life. But there would still be traces. The life experiments, all three of them, all were inconclusive. So we need the new technology we've developed in the past 50 years and maybe land near the poles. Because the poles are not just carbon dioxide ice. Underneath them is water ice. Where there's water, at least to our biology, there can be life. But there's a lot to see still to study on the red planet. So we'll look at some of the geology of the red planet.
Is there any atmosphere in Mars?
I'm sorry?
Is there any atmosphere in Mars?
Any activity? No.
No atmosphere.
Oh, the atmosphere is extremely thin. If you went up to about 45,000 feet above the Earth, approximately, for about 45,000 feet above the Earth's surface, it's about the same density. So if you took your helmet off, first you couldn't breathe the carbon dioxide anyhow. So you have a race between suffocation and your head freezing, because the average temperature in the summer is about minus 30 Fahrenheit. So, it's a terrible choice. What can I say? Okay. This is the western edge of what's called the Tharsis region. And the Tharsis bulge, which apparently is about 6 miles high above the mean surface of Mars. And it's about 2,500 miles across. If this was brought to the United States, it fit very comfortably across us. And you can see something else here, too. These are clouds, what we call $20 word, orogenic generated clouds. In other words, landforms forcefully water and carbon dioxide out of the air in the form of snow. So we have a little bit of cloudiness here and there. But again, it's kind of rare. Okay. We have dune fields, just like our sand dunes here. There are wind streaks over to the side here. You see very, very fine grain material being blown by the direction of the wind, primary wind. And dust storms that sometimes cover the entire planet for months. Usually, when it's at closest approach to the Earth, and we're coming up on that in 2027 and 2031, if I remember correctly, in that period, it'll be very close to Earth. It'll be great to be able to observe with a telescope, and I'll guarantee you, I'll bet $5 right now with anybody, it's going to cloud over because of the dust storms that will be kicked up. But we'll see. Can't win, This is why it's called a mysterious planet, because it doesn't give its secrets very easily. Okay, Martian winter conditions. Water and carbon dioxide ice layers at the pole, see over here. But early in the morning, this was Viking 2, if I remember correctly. Yeah, V2. This is all frost. A mixture, in this case, of carbon dioxide and a little bit of water. About an hour later, the temperature rose just enough so all that thin coating just disappeared, just evaporated. And of course, the polar caps we close in on, you can see there's quite a bit of glaciation through here. This layering is still there as a remnant of a much larger cap. And we look at this And when you see something like this on landform here on Earth, we think water. Was there liquid water in the past? Apparently, yes. Maybe even oceans. But we're talking back, well, if the dinosaurs had telescopes, they probably could have seen the last remnants of these oceans. But this is really cool when you think about it, because here you have this big valley over here, and apparently, if you're into Norway and you like fjords and such, you got a whole stack of them here, 2,500 miles across. And then you have some of the volcanoes up here. So at one time, maybe about 3.5, 4 billion years ago, but the ocean water would be salty, like we have here on Earth, but acidic,
Oh,
like drinking vinegar, which would not be good. And believe it or not, even under those conditions, you can still have life. In Curiosity, when Curiosity landed on Mars, robot that moved quite freely across the surface and took some wonderful photographs. Now, here's a question for the audience. You have two photographs here showing what looks like a section, like a tributary area of a stream. One of these is Mars, one of these is Earth. So the question to the audience is, how many people think that this is Mars? Any hands? Okay. How many think that this is Earth?
yeah.
Yeah. The other way around. That's exactly right. Little devils. But yeah, but however, we still see the same kind of effect, because what's happening over here is that water rounded all these pebbles. And the water's not there anymore. You cannot possibly have, for any real long period of time, liquid water. But at one time it flowed freely. And also there's Curiosity, our little friendly robot over here, and Mount Sharp, which is still climbing today in that area. Okay, and that's Perseverance now, over here, a different part of Mars, and Ingenuity. And this is extremely cool. This is a helicopter. Had it here, it'd be about this big, stand about this tall. And it was only supposed to work for 10 flights. Because it was recharging batteries, they didn't know if the electronics would handle the cold. Many other factors, it did 74. Before finally, when it came in for a landing, these rotors got tilted over. Apparently a gust of however a little wind is there, pushed it to one side and it couldn't fly anymore. So it was a little helicopter that could and did. It's amazing. But as Perseverance was walking across Mars, it started taking samples of various rocks and such and left breadcrumbs. It made 2 cuts in various rocks and materials, left one on the ground, they know exactly where they are, and stowed another one aboard itself. So say you had a big, massive sandstorm that covered up this entire area. You'd still be able to go there, just have to find the robot, and it has a cache of these samples. So it's kind of like making sure, a little redundancy to make sure that we can get the samples one way or the other. Okay, and there are the breadcrumbs. They don't make breadcrumbs like they used to, but they're beautifully sealed up, and hopefully either we'll be able to pull the pieces right out of the sample cache on the vehicle, or maybe we'll walk backward, nice little run, and pick up all the other samples. So we'll see. That's for future. Okay, Mars Insight lander went there in 2018, and it listened for Mars quakes. Yes, this is solar powered. This is these pictures, spacecraft pictures, by the way, taken on cameras that are able to look down or over to the side or whatever of themselves. This is a self-portrait. These are solar panels and the rest of the equipment, cameras and such. And this is a seismograph, which we use on Earth to listen to and analyze earthquakes. Well, Mars, turns out, it has some activity underneath its surface too. Not as much. So InSight's details, that's that seismometer on InSight and some Mars quakes. This is a preliminary image, a cross-section of Mars interior. Apparently, it still has a relatively warm, not a hot core. It's smaller than Earth, about half the size. So it's cooling down faster. But this gives a rough idea that maybe there was some, and still may be some volcanism somewhere reaches the surface. Its effects certainly have. Okay, in 2021, we are not alone, as I said. This is the only landing so far that the Chinese rocket scientists and such have attempted. They did a pretty good job, I dare say. In 2021, the Zhurong lander was able to communicate. I think it communicates directly. I got to check this out. I think it communicates directly with Earth, but I'll have to check. But you can see the back shield and the parachute. And a lot of people have looked at this picture and say, this looks awfully suspicious to us. Why is it so close together? We have the same thing with the other landers, the Viking landers, but we'll see. And on top of that, unfortunately, the Chinese have been very quiet about their information. So it may or may not be real. I think it's real. I like to think that it is, because this is our solar system, folks. All 7.5 billion of us are on this rock, and the rest of the solar system is our domain. Maybe we can end up sharing it. We'll see what happens.
It kind of looks like Earth.
I'm sorry?
I say it kind of looks like Earth, like the deserts on Earth.
Very good. Very good observation. That's exactly what it looks like. And it is a drier desert, though, than anything here on Earth. And I mean, you're not going to see grass growing here, I'm afraid, but you will find incredible mountains and other things. And you might ask, why is it so hard to land a spacecraft on Mars and then operate it? And why is it so to even observe it here from Earth? Well, a couple answers. Okay, first things first, the nasty atmosphere. Mars' atmosphere is only 100th that of Earth, but it's still way too thick for any spacecraft to ignore. You come in there without a heat shield, you will burn up.
Oh.
On Earth, the same trick, of course, but it's a denser atmosphere, so you can still use parachutes. You can use the dense atmosphere to slow yourself down and have a parachute and land. And this is also an analysis of it. Most of the atmosphere of Mars is carbon dioxide, about 96%. Argon, nitrogen is a little bit up there, but the array of other trace gases, all sorts of wild stuff. No, not the planet. This is krypton. That's a gas on Earth. Neon, and ozone, which we're seem to be losing. Here on Earth, we have quite a variety. Look at this wonderful number. Oxygen, 20.9%. It sustains life here on Earth, no matter, even if it's dissolved in water, you have fish. And you have bacteria running around. On the land, the plants give us oxygen and pull the carbon dioxide out of the air. It's basic biology for Earth 101. The atmosphere of Earth also has a lot of nitrogen in it, which means we have bad forest fires, but nothing like we could have with this pure oxygen. There are all these wonderful trace gases all through. So it's a bit complicated, but in a sense, it's kind of also simple too, because we've been analyzing our atmosphere and now on the surface of Mars for maybe the past 150 years. With Mars, it's only been the last 30. But we again know a lot about both planets. Okay. Now this is sunset on Mars. And if you notice something kind of funny about this picture,
It kind of looks like Earth when we look at the sunset from this planet.
well, something like that. Notice the blue. The atmosphere is so thin, the blue light coming from the sun goes right through it. Here on Earth, our atmosphere is dense enough so we have red sunsets. So yeah, it's all absorbing it. And over here, there's not enough to absorb. So
It's just blue.
You make an interesting set of blue moon, it'll be blue sun or something like that. So who knows? Or maybe a blue sunset. In that case, it's just haze. There are almost no clouds where this was photographed. Looks very cool, though. Okay. And there are water clouds, however, because if you have a big enough volcano like Osea Mons over here, and the wind goes over it, orogenic or land-generated clouds form. Look at this. This is all water ice over here. So I dare say if you need to get water, you send up a balloon and just pulling the atmosphere and pulling this water crystal. Though, of course, there's probably a lot of it buried underneath the surface of Mars, too. But it's way too thin to breathe. Okay, Mars is a little bit, tiny bit of nitrogen, tiny bit of oxygen, a little bit of argon, so that tells us probably indirectly that there were radioactive elements in the formation of the planet. Look at carbon dioxide. If this planet was where Earth is, it would have a greenhouse effect, beat the band. Here on Earth, mirror opposite. We have a lot of nitrogen, good for the plants too. Oxygen at 21%, argon, which indicates in this case radioactivity on Earth, and then carbon dioxide is kind of little. And there's always been controversy that our industry and such is creating tons and tons of carbon dioxide, and it's going to superheat the planet and destroy all life. That's how they were saying that in the 90s and early 2000s. And I'm saying, wait a minute.
A little bit of that.
Yeah, well, it is bad. Global warming is not the best thing in the known universe, but it happens on planets, and we can control it, and we are slowly but surely working on that. Or to put it another way, if I have to have faith in something, I have faith in science and technology, and not just saying, well, we'll do something later. It doesn't work that way.
Honestly, I thought it was a lot worse.
No.
Not that bad.
It's not quite that bad, actually. I'm more worried about different kinds of pollution, carbon monoxide, other chemicals and such near cities and everything. That needs to be cleaned up for real. This over here, though, this is a good mirror. It's the atmosphere. We can't just jump on a rocket and go somewhere else. The nearest Earth-like world probably is about probably about 15 light years away. Or to put it another way, if you were going at the speed of light, it would take 15 Earth years to get out there. Now, for you inside the ship, you wouldn't age as fast. You may age another day or so, a year or so. But getting there, how do you get to another star? We don't have the technology. We have lots of wonderful science fiction, some fantasy, a little bit of theory, but we have no way of building a vehicle, walk into it, hit a couple buttons, and bang, like in Star Trek, and he pick a series, and suddenly you're hundreds of light years away. It doesn't work that way, at least not yet.
I kind of wish it did. It'd be kind of cool. See all types of different planets.
Oh, yeah. I mean, well, don't look now.
Okay.
But you and I, all of us here, and everybody else on this planet, no matter what they may think, whatever they have loyalty to, their intellectual level, it could be children, or the great thinkers of the world, and everything in between. We have one big commonality, a great one. We have ourselves. We can do this. If we put our minds to do anything, I dare say, we could get to Mars. Probably if we start right now. Somehow they have a great revelation. We could get there in 15 years, easily, and keep on going up there and start colonies. The nearest star is a lot harder. That would probably take a vehicle. It would take 15 years to go 4 light years. But still, you get there. But right now, we are here on Earth, and this is what we got to work with at the moment. So tune in 20 years. Okay, so what would it look like if you were standing on the surface of the red planet? This is a nice shot over here, 3 of them. Unprocessed color. This is just raw data from Mars. There's no calibration. They didn't have a color chart to work from. Just quick photo. Natural color using calibrated data. This is what you would see. This is why they call it the red planet. To my eyes, it's more like an orange planet.
Yeah. So there's a little
And then white balance, meaning that some of these things out here are white in color. This is probably closer to the truth. If you stood there in your spacesuit and you pulled up the visor to keep and turned your back to the sun so you don't get blinded, even out there, it's still going to be a bit blinding. This is about what you would see, which is really nice. It's kind of like an arroyo, such here on Earth in a canyon.
the Grand
So,
Canyon.
and we have been doing a lot of exploration. From 1971 to 2021, and I apologize for that. I could not find on the web a map that's any younger than 2021, but still there's a lot of stuff out there. We landed a lot of things there and put stuff in orbit. Various countries, landers, rovers, helicopters. We have one so far. Penetrators. The green dots show success for a given mission. Some, unfortunately, they failed. You see it in red. It's not as, it's out there. Next year, I think it's in January, Mars will be, every other year, it's close to Earth. And we'll be able to show you Mars. You may not be very impressed with it because it's still going to be quite small. But we can show it to you through the telescopes. But there's been a lot of landers and rovers in this 50-year period that's designated over here. There are a lot of names through here. Opportunity, Mars Pathfinder, Vikings 1 and 2, Phoenix 1, which came very close to here. And where you see green dots, that's success. So we're about 50-50 right now, we're batting about 500, which I'm told in baseball is pretty good. Okay, so coming up, as I mentioned before, Mars is going to reach opposition on February 19th, 2027. It'll be located high in the east at that time. Of course, it's going to be cold, naturally. In the constellation of Leo, close to a bright star called Regulus. The nearly full moon nearby, though, is not going to interfere with viewing. Now, this is the date of opposition. It's near closest approach to the Earth. For a couple months before and a couple months after, you'll still get a good image of it with our telescopes here, and you're more than welcome to come back for that too. Even before that, we got a lot of stuff we can show you out there when it's clear. The red planet will be fully illuminated, lit up by the sun as seen from Earth, visible all night on that night. Mars will have a diameter of 6. This is going to be meaningless to a lot of people, I'm sorry to say, but it'll have a diameter of 16.5 arc seconds in diameter. In other words, if you look at the moon and you look, I think it's the crater Aristarchus, that's about the same size. So it's going to be a good size image. At a magnitude minus 1.45, you can't miss it. Brilliant orange, they call it the red planet. In my eyes, everybody, other observers, it's orange, but you can't miss the darn thing. And you're welcome to come back here in the time in between too, but especially around that, we'll probably end up having a special night just for the public. Okay, and this is just a quick view of terminology. When Earth is directly in front of, or very close to in front of, a given planet that orbits like Mars outside our orbit, it's called opposition. This is the best time to be able to view. It's fully lit up, and it's usually closest to the Earth. On the other hand, if it's on the other side of the sun gets in the way, obviously. It's called conjunction. The outer planet's orbit versus Earth's orbit. So this is just a quick overview of the positions over a period of 2 orbits of Earth, Mars, and the Sun. Okay. Now, because you can see, here's Earth's orbit, here's Mars. You can see it's a little offset and somewhat wider. So in 2012, Mars was over here, it was very far away. Yeah, 2025, you can see it's very far. And December 2nd, 2022 as well. So we're hoping by 2027, it's going to be much closer, and it will be. So that's a good time to be able to start to view. Of course, it's going to be in January when this happens, so it's going to be very cold here. If you do come back so we can show it to you, please bundle up. The domes here are unheated and uncooled, if you noticed. That's to make sure the telescopes, they come up at the same temperature or lack of it, so that the image is nice and steady.
No.
Yeah. Yeah, thank you. Well, I don't want to use a $30 word, but you're right. It'll be you have to acclimatize the telescope so you can see it cleanly. Okay. And how to view? The larger the telescope, the better the view. That's why we have a 24-inch telescope, which, by the way, I don't recommend, because that aperture doesn't just magnify the image, show detail in the image. It also magnifies the atmosphere, and you see twinkle, twinkle, little star. Remember that?
Yeah.
Happens with planets too. So it depends on what we're seeing at the observer's site. You need at least a 6-inch aperture, and you folks are lucky. We have a 10-inch refractor over here. Its main lens is 10 inches across, and that one over there is 24 inches across in its mirror. We will be using a number 25 photographic filter, red, or number 30, which is best, magenta, because that lets blue and red light through and suppresses the green and yellow. So the detail contrast on an already orange-red object is going to be amazing. And you really should, we can't do it here, get away from city lights into a safe dark sky site and dress warmly. Like I said, these domes are not heated, so in January, when this all happens, make sure you come in here well bundled up. Okay, so now how about some current news about the red planet? Okay, this was photographed from NASA's MAVEN spacecraft back in 2024. And all these little dots here are the equivalent of the northern lights. So there's no general there's a very, very faint magnetic field here. But apparently the atmosphere still interacts with the sun's, where you get a type of northern lights.
Kind of looks like it's glitching.
Yeah, true. Okay. Yacero crater from Perseverance. I mean, to my eyes, this is kind of like the American Southwest, except it's much colder. I mean, like average daytime temperature when the picture was taken was about -10 at local noon. And we have all these wonderful layered rocks over here. When you look at a layered rock, you're looking at a book in geology, whether it's a lava flow, which maybe most of this is, but in certain cases, if it's sedimentary, like sandstone or limestone, I don't think we have limestone here, but definitely sandstone. That's a great way of preserving fossils, if there are any. Okay. And running over something as a method of discovery. Curiosity in Geddes Vallis. Curiosity rover drove over a few rocks and revealed the presence of sulfur crystals. Well, that's a shame. I wanted to get the nice crystal of Martian sulfur. What happens? It runs right over the earth. But that is an amazing discovery to find that. We know there are volcanoes up there. We never dreamed we'd be able to see crystals of the material without digging into the surface. And, well, let's put it this way. The asteroid belt's right next door. So this might be a sample from an asteroid called 4 Vesta. Vesta was the 4th asteroid discovered. Now there are known hundreds of thousands of them. It's a rather large object, too. And we find pieces of this here on Earth. But look at this. This is something I want on my mantle. My little piece is only about this big. It's a slice. Yes.
How big is that piece in the photo?
What's that?
How big is the piece in the photo?
You wouldn't want to sit in the house. This is 18 inches across. That would not fit on our mantle. It would fit in the stimulated furnace. That's a good piece. I wouldn't mind getting this, taking it home, cutting it up, and selling $100 a gram. Seriously, it's beautiful, and apparently it's sandblasted too.
They get there.
How they get there? Collisions with other asteroids, and then Mars just happens, just like here on Earth, just happens to sweep it up. And we got lucky in this case. So did Mars. I want to go back here, and I want to get my geologist pick out.
Do they land here in the States or like?
Oh, yeah.
Yeah.
Where do they usually land?
All over the planet, actually. Yeah. Yeah, and they just had an article about that too. Turns out they found chemicals for life. No life. Okay. Nothing crawled out and attacked the Piscataway or anything like that. But the chemicals of life were found there.
That's like
So that's a major discovery. So the homeowner that meteorite crashed into a property, he's doing very well, thank you.
Yeah.
And, but here you are. This is a specimen. Like I said, I'd love to have a piece that big. Of course, we're probably have to keep it in a vault somewhere.
Kind of large and fat.
So Perseverance also did samples. Perseverance samples from Chiava Falls appear to show signs of previous life. These pieces through here. When they were tested, they had organic materials in it, and we're not quite sure where it came from. There was no contamination on the equipment aboard Perseverance, because we can subtract that. So we are thinking that maybe we're just looking at tiny samples, what might have been, say, fossil algae, like the green pond scum that you see here on Earth. So in other words, if these were alive, we're probably talking the order of a 500 million years ago. And I had to put this in avocado rock. I don't see an avocado here. I see a Mexican hat, a sombrero. But okay, one guy's sombreros, another one's avocado.
Well, it's the pit in the middle.
Okay. Well, that explains. What? Okay. Rochette rock core samples. They took two of them. One sample was brought aboard the rover. The other one was left like breadcrumbs. And we know the path of the vehicle, so we can go send another robot there to pick it up. Or better yet, send humans. It'd be more fun. Get a lot more discovery done. The famous blueberries. When the first lander, years before, had touched down on the red planet, all around it were these little bluish to color photographs, objects. Apparently, these are what they call concretions, minerals that in water collected together and form these tiny little things here. Now, if you try eating these blueberries, it's not very filling and it'll break your teeth. But it does show the presence of water. Okay, and speaking of such, this is at the Martian North Pole. This has been magnified and distorted a little bit so you can see the extent of the carbon dioxide, and at the very top, the water ice. Yes, frozen earth, frozen type water all through here. So we don't know. There may be some evidence of past life here. We're not sure. However, the only way to find out is to go and find out. And Mars is not completely inactive because we have the volcanoes. So those volcanoes may be as old as 3 billion years old. Apparently, there's enough geology moving that causes a landslide, Marsquake. This is on the edge of the North Polar region. And you can see that the Viking orbiter captured this coming down. So you wouldn't want to be there, I'll tell you that much. Because a Marsquake, earthquake, that kind of avalanche still would hurt and maybe even kill. So it's not as safe. Space travel has always been dangerous. This is more dangerous. Okay. And I mentioned before, Perseverance, sampling Mars. They gave various names to the sites. And this is its path. At the time, I don't have it on here. Okay, at the time, it had only gone up this far, which is still quite a bit of work that the rover traversing. And it's gone even further. It's still moving. Caching core samples in soil, carrying the retrievable specimens in Gale Crater. And this just in, as they say, a newly discovered giant volcano. We knew about, at the top there, Olympus Mons, Mescreus, Pavonis, and Artium Mons. We had no idea there was another volcano, and we were staring at it. And finally, the proper people looked at it and found what was left of a giant volcano. 280 miles in diameter, elevation of 29,600 feet, higher than Everest. Active from ancient to perhaps modern times. And it was disguised, if you will, as the endpoint on Mariner Valley, Valles Marineris. There it is. And I love this name too, that area that it formed in, Noctis Labyrinthus. What a wonderful name. The Labyrinth of the Night. Here it is, staring us in plain view, and we had to stare at this thing to finally have someone say, hey, wait a minute. There it is. Apparently what's left of a giant volcano, and at one point, its altitude, its height, is 9,000 meters. That's about 27,000 feet. Apparently, there must have been a major explosion that blew most of it apart, but we still have quite a bit here, and it's right by Mariner Valley. So this is a very active area here geologically. At least it was. We think the activity finally kind of tempered down maybe about a quarter billion years ago. But in geology, that's last week. Okay, and somewhat closer, there's a glacier, what's left of one over here. It's finally identified back in 2023. There's very glacial ice, pyroclastic deposits, in other words, volcanic quote-unquote ash. even sulfate source, and maybe water ice below. And then we have some stuff we can't figure out called blistered terrain. I think it might be rootless cones, say steam vents, maybe. Because where you have volcanoes, you usually have other activity with dealing with water. All right. More importantly, if you look back at those volcanoes, we've identified, you can see almost 100 windows, skylights. There may be caverns underneath a great science fiction story, the caverns of Mars. Remember, if you write it, I get credit for the name. But they're all over the place here, which is very similar to what we see here on Earth, even some areas, certain areas of the moon. And relative altitudes. And this is interesting. Maybe you've already started to pick it up. This blue area over here is almost 8,000 meters, 8 kilometers, 8,000 meters below the mean surface here. And then you've got this set of volcanoes here. Then you have Noctis Labyrinthus, which is a nice rip valley. Will go out to a polar sea. So at one time, this must have been incredibly water-rich, wonderful area to work in. Wouldn't mind taking my geologist pick up there myself. Okay, so the story to date, and this is actually getting a little dated, but it's a good representation. We have sent lots of probes out to the moon because it's nice and close. Mars has always intrigued we humans because it seemed to be, at one time to our science, like almost a baby twin, kid brother, if you will, to the Earth. So we send a lot of spacecraft down there. The environment seems to be pretty good for life. It's cool enough, maybe a little too cold here and there. Not like Venus, which has been likened to volcanic hell at 800 degrees Fahrenheit all across the planet. Mercury has no atmosphere. It's way too close to the sun. And the next planet out from Mars, of course, is Jupiter. That's a gas giant. Almost all hydrogen, helium, and little impurities that give a wonderful cloud bands to it. Mars and Earth are the places to go. You want to find life, wonderful life here on Earth is astonishing. There may have been, or maybe there still is something here, which is why we sent all these probes out, trying to understand the planet, look for life.
So,
Maybe eventually humans will land there. I'm hoping within the next 20, 25 years. Okay, I'm gonna let the cat out of the bag. I'm 71. By the time I hit 95, I'm hoping to see the first boot print on the surface of the red planet. So I'm taking Geritol bodies, making sure I have my vitamins, and occasionally I sneak in a good steak. But there we are.
so it's possible it's fossils on Mars?
I'm sorry?
I say it's possible that's fossils on Mars.
It might be. We got to go there. We have to go there and find out. Okay.
They were fossils.
Fossils, very good. Maybe. Big maybe. There have been, I'm glad you brought that up. I almost went shot right past it. Thank you. We have some Mars rocks, Mars meteorites that have come to Earth. 2 or 3 of them have structures in them. When we've cut them open, we've polished them very, very thin. And some of them look for all the world as if they were once bacteria. Now, where there's bacteria, obviously there's life. It may not be, a Martian saying, take me to your leader or anything like that nonsense. Or, or God forbid, the Klingons or something like that. But we might be able to find that there was evidence at one time, and maybe there still is up there. The only way to do that is the Explorer's Creed. Go take a look for yourself. Hopefully. 1964, I love this. 1964, this was a proposed base on the moon. So I recolored it a little bit, and now it's Mars base, which they were thinking of too anyhow. Those were the days when the atmosphere on Mars was believed to be only 10% that of here. So you just needed a quick oxygen mask, and you put on a heavy coat, and you go out traipsing around the red planet. Good luck. But this is the right way to go. You're going underground. There might be some heats. There are heat sources there which you can tap into. So, and you have to have an observatory. Comes with the journal. And getting ready in the 1990s, proposed rovers. They were practicing to see how well back then old Apollo suits would operate if you were on Mars. Earth's gravity is one gravity. The moon is about not quite 20% that here because it's smaller. So Mars is somewhere in between, about 0.5, 0.6. So you could still take a nasty fall. But they wanted to see if the suits would work. Turned out they did pretty well. And they tried out equipment that would eventually be strapped on the arms, on the outside of the suits. And no one told them, though, that you can't get gasoline up there. But hey, they only had limited funding in the 90s. Okay. And there are other dangers up there, too. It's darn cold normally. But then you have dust storms that, annoyingly to observers here on Earth, have a tendency during times when it's a good time to view it, what's called close opposition, on as close as maybe 35 million miles away. It's very close. And then you have a dust storm. And over a period of about, it was 10 days, full sun, dimmer. And that's for weeks on end. So you're going to have a lot of good lighting because some people can't handle something like that. Okay, this was Hollywood's idea of Mars. Okay, again, I'm showing my age, okay? Currently, I'm 71. Ouch. But back when I was a kid, I was not even 10 years old yet. I had this in my sights, 1964. Occasionally you see it. And until Friday shows up, it's a pretty good rendition of the Mars of 1964, Robinson Crusoe on Mars. That's actor Paul Mantee looking into a mountain pass. There's all sorts of great activity going on in there. And the suits are black because out there, that far away from the sun, it's darn cold. So it's a pretty well thought out movie setup. Okay, planning for the future. The whole idea is to send more rovers with small helicopters to be able to bring samples back to a collection system and then stick that into a rocket to rendezvous the return vehicle for the outsized Earth hole in the top there. Okay, maybe this is Mars operations 2040, I hope, and 2044, and a distant cousin to Ingenuity being operated by a spacesuited person, and she's seeing what's on the next side of this ridge with that vehicle. So, in conclusion, that imagination is as vital to any advance in science as learning and precision are essential for starting points. That was Percival Lowell, American planetary observer. This guy believed in the existence of canals. Matter of fact, he wrote two books. One, Mars, the Red Planet, and the other one, Mars and its Canals. And he had postulated, remember this is the late 19th, early 20th century, very romantic Mars, where the heroic Martians, in a desperate attempt to stay alive, were taking water from the icy poles, and we knew that the poles melted because of over seasons you could see it, and trying to stay alive. A very heroic idea. Sorry, it didn't work too well. However, he did establish an incredible observatory, which has always been on the forefront of planetary astronomy since about the 1910s. But he's right, though. If you don't imagine, how do you dream? And if you can't dream, well. And finally, what can be more fantastic? This is amazing. You all don't know. Hardly anyone seems to realize we are living in a golden age, the second golden age of exploration. And everybody wants to make a war of that guy over there because he doesn't like this or he doesn't believe the way I do or something like that. We make weapons of war. This is another weapon against the war of ignorance. All that you saw, that's all for the collective knowledge. One of these days, there's going to be I hope, there's going to be a great revelation. We're all going to wake up, even the people in the middle of the night on the other side of the earth, and they're going to say, hey, wouldn't it be a hoot if we all kind of work together and try to solve all these damn problems here and then get out into the solar system and all work is for one common purpose, not communism, folks, no, just a common idea. I'm hoping that day happens. I hope it happens during my lifetime. I figure I got about another 25 years. Sorry to my enemies, too bad. But the whole thing, and I'm hoping that we can share the new exploration. And I have to thank my wife, Bonnie, Mary Duca over here, who lets me give these talks. Sorry about the pontificating. I try to hold it down, but hey, Cliff Ashcraft, a fellow astronomer, a darn good researcher, NASA, European Space Agency, and all our observers here at AI. Okay, and thank you for attending, and good evening.